All right, maybe, oh, here we go. Hello, Michael, you're the only one on. I'm ready to start, so I'm going to just start right now. There may be more people hopping on. I guess we'll see. All right. This is the email I literally sent out like about a minute ago. Sorry about that. We had issues in the other class as far as getting some of the stuff to work in GitHub, so I was trying to fix those. All right. As it says here, today we will go over more MySQL material. I have set up a repo for you. I'm going to be doing that, if not every day, at least most days. So if you go out there, you will find, if you do go out there, let's see, change this, rid of that and that. All right, so if you go out to that repo, what you will find is the following. All right. The first, I did take all of those slides that I had from that Brad Traversy class, and I pared them down, threw out what I didn't think was that relevant, kept the rest, and added a few more things. There's a homework assignment for you that we'll talk about later. I did fix that database from yesterday, so we'll talk about that later. And there's a picture or a schema of that database. All right, so we've got all that. So I am going to start by opening this folder called all, and I'm going to start going through what's in there. All right.
Mr. Scott,
Yes.
Whenever I go to open that GitHub page, it just shows a 404 error. It says there's nothing there.
That's fantastic, isn't it? All right. So rather than trying to fix that, I think what I'll do, I don't know how big this is, so let me look. Well, it's too big to zip and send to you. So I'm going to go and try it again. We'll see if we can get it to work this time. So.
Okay, and then I had another question regarding actually like pulling stuff from GitHub.
Yeah.
Is there a way to just pull like that whole folder, or do I have to go into each individual folder and kind of, I wasn't able to I didn't see a download or anything like that on.
Well, I'll tell you what, let me try this and then I'll show you what I do. Okay.
Yeah, absolutely.
All right. All righty. So let me get bash here. That's not good because it says everything is up to date. Crud. One thing that is possible, but I know I moved it over, but let me look. I mean, the stuff's there. I can see it on my screen. All right.
I'm able to find it just by going to your GitHub and then just going to your repositories and going that way. But
right.
Just for whatever reason, that link, yeah, it wasn't working.
Okay. All right. What I do though is up in the upper, near the upper right-hand corner, I click the green button that says code, and then I go down to the bottom and I download the zip.
I did not even see that. That'll do it. Thank you.
Yeah, sure. All right. So let me change my. Unfortunately, I got a boatload of garbage open here, so I'm going to try to close a couple things because what the system does is everything I've got open, it has a window in there for my sharing. And it had 24 windows open there just a second ago, and that's ridiculous. So I'm trying to minimize this is what I'm telling you. Just about got it pared down now. Shouldn't be too bad. So let's see. Well, let's see now if we take a look. If I go in and change my share, there shouldn't be 24 windows open anymore. Now I've cut it to 12. I guess that's better than it was. All right, Michael, can you tell me, do you see on your screen right now something that says MySQL 8.0 reference manual?
Yes.
Okay, then we're ready to start. All right. Hopefully, as I peruse my way through here, they're not going to disappear. All right, this is the magical thing, for lack of better words, to find almost anything MySQL. All right, we're going to talk MySQL. I've actually found a bunch of presentations that I created. Like yesterday, I gave you those node ones. I'm going to give you some today for MySQL. And unfortunately, there's more of them. And also, unfortunately, I didn't find them till right before class. So I'm doing them literally off the top of my head, but that should be fun anyway. So when you go through the reference manual and you look through the side here, notice here, for example, there's the data types about halfway down. And if you know, there's other stuff that's in there that you'll probably use too. Now, if I change from this slide, does yours now say chapter 11 data types?
Correct.
Good. All right. So this is right from that. I just clicked that data types link. All right. The reason I'm telling you that is eventually you are going to create your own database schema. All right. And when you do that, all right, and when you do that, you're going to have to know things like data types. All right. So then there's functions and operators. So the major functions that are available in MySQL are in here, and these are categories, so you can click on any of those categories and find out more. All right. And this talks about data definition and data manipulation at the top. You may or you may not remember this from when, but we did go over this back in the days of C# when we talked MySQL. And that is anything that says data definition language, that is create, alter, and drop. So in other words, that's allowing you to change the schema or the way that something is set up behind the scenes. Those are DDL, data definition language statements. They are create, alter, and drop. On the other hand, the DML or data manipulation language statements, that's our CRUD stuff. Those are select, update, insert, and delete. So if you need more on that, you can go out to that particular link is what I'm telling you. All right, finally, we've been using PHP MyAdmin. There is another tool. You don't have to use it. You don't have to download it or anything else, called MySQL Workbench. And you may find when you look at this that you like that better. All right. So there is the information for that. So just in case, all right, you look at that stuff and you think, oh, I don't really like using PHP MyAdmin. All right, that's MySQL Workbench. And John, for you and Clayton that just came in, all I did, Michael told me I did send you an email today, but it sounds like the GitHub repo, there might be something screwed up with the address. You might have to go in and basically work on it to get it to work, but I'm going through that stuff that's in there right now. All right, the first 5 screenshots that I had for you, just going to go back to the beginning very quickly. This is the MySQL reference manual, and the key thing is dev.mysql.com. That's the magic if you want to find out things MySQL. So that was the manual itself. There's the link to data types, which is chapter 11. There's the link to functions and operators, which is chapter 12. That's the link to the different type of statements. And I just mentioned the DDL, the data definition language, which is create, alter, and drop, which allows you to modify or remove schema, and the data manipulation language statements, the DML, which I equated to CRUD, and those are select, update, insert, and delete. Finally, this is where you guys kind of hopped on. If you don't like using PHP MyAdmin, there's another one that's called MySQL Workbench. Some people like using that. To me, it's what's the old saying? 6 of one, half dozen of the other. They're very similar in nature to the way they work. All right. Finally, the thing ends here with a glossary. And the only reason I bring this up is it's got a whole heck of a lot of definitions of good terms. So if you're confused on anything database, there's even stuff in here like API and other things as well. All right. So I'm not going to lie. I've tried to be totally transparent. Again, the next several slides that you see in here, and this is probably going to take maybe 15 minutes. I don't know. But I'm not going to sit and read them to you. But these are things that I got from that Brad Traversy database course that I took that's 8 years old. But you should now understand what a database is. You should understand what database data is. You should understand what a database management system is and what a database application is. So let's very quickly go over those, and I mean quickly. The data is the data that goes into the database. You're going to see more of that in just a minute. The database management system we are currently using is MySQL. MySQL is an example of a relational database management system, or an RDBMS. All right. And the database application, hopefully we're going to start on that tomorrow, but we're going to see how it goes. All right. So these are the definitions that are given by Traversy. Again, I'm not going to read. MySQL is an example of a relational database management system. You can see how he's defined it. I just look at a DBMS as it's a thing that allows the user to interact with a database. All right. And sometimes it's going to be through a GUI method, and that's what we've looked at with PHP MyAdmin. But you can also typically do it through a CLI or a command line interface. All right, here's a simple example that he took. So you can see in here we have what? We have 3 records. Each record has an ID. Each record has 3 fields, a first name, a last name, and an email. And again, columns and fields are used interchangeably. Rows and records are used interchangeably. All right, and the name of this happens to be users. All right. By now, hopefully, you've got at least a comfort level with SQL. And if you say, not really, Jeff, we're going to go and we're going to look at some more stuff today. And what I've done is, and I'm not lying to you here, I wimped out a little bit. I did come up with a thing that's got, it has 22 problems in it. I created the first 17. I'm asking you to create the last 5. And if you say, I don't know what it means, we're going to look at it by the end of class. But you should understand what SQL is. The key thing about SQL, or one of the key things, is it's almost as old as I am. All right. It's about 55 years old. All right. Since it was created. And as it says there, it allows you to perform CRUD. That's what we're going to be using. Now, the stuff that's in here, really the only thing you're going to have to understand, there's a couple of things. One is foreign key support. All right. And another one is security, because we'll look a little bit at that. But by now, you should be familiar with what a foreign key is. If you've forgotten about it since we went over it, you'll probably see examples a little bit later. All right. There's a lot of platforms that you can run MySQL under. MySQL is an example of a CS, or a client server architecture. All right. The server, as it says, that's the program that basically, this MySQL D, you don't want to play with that. It's the program that actually does the interaction with your database itself. What you use is a GUI tool. You're the client. So what you're using is a GUI tool where we're either using, and which we have been using, XAMPP, or, and I think I showed you this the other day, but we'll look a little later on how you can also use XAMPP and use it in a CLI, or a command line interface. All right, utilities, as it says, this is an example, the MySQL D_safe. That's a monitor basically, all right, that you can set up to look for people trying to break into your system. This is the program in a little bit of a GUIized format. Now, where it says PHP scripts here, no, that's not us. We're going to be using Node. All right. So you're going to be using Node. One of the packages through Node that you can use is MySQL. All right. And we're going to be using that. We're going to be using a GUI client, that being phpMyAdmin. And we're going to be referencing the MySQL server, which is going to hold all of our data in it. All right. Now, the storage engine that we are using in here is InnoDB. I laugh because Traversy calls it InnoDB, but that's the first time I ever heard anybody not call it Inno. The bottom line is it's the default, and you don't have to do anything special to be able to use it. All right. It says it offers a lot more features than MyISAM. ISAM is indexed sequential access method. That's the old way of doing things. There were plenty of problems with MyISAM, and there still can be. You still can use it. But notice it says uses row level locking. What that means is you can be granular enough with InnoDB that if you've got a bunch of people sharing the same database, one user can lock one record in that database and leave the rest of that table available for other people to look at, manipulate, or whatever. With MyISAM, it was table level locking. So even if you only wanted to change one record, that in a table that had 1 million records, you had to lock the entire table, which could make it hard for other people who wanted to work with it. All right. InnoDB says it allows for parallel insert, update, delete. So in other words, it's more asynchronous, where MyISAM is more synchronous. And this is the big one. InnoDB naturally supports foreign key functionality. All right. Now, MySQL has 3 major data types. There are 3 categories. There are subcategories of these, but numeric, string, and date and time. So when we start to break those down, all right, with the numeric, you've got both signed and unsigned. By now, because you've had this kind of stuff in the C# class, it should make sense to you that unsigned can't be negative, but their range is twice as large. It starts at 0 and is twice as large as something that's signed. If it's signed, it can be positive or negative. And you can see the example he put on the bottom here, that if you've got an int that's signed, its range is -2 billion plus to +2 billion plus. But if it's unsigned, its range is 0 to 4 billion plus. All right. So, I mean, a lot of the work that you do in here, it makes, if you're going to do this, it actually makes sense to use things there that are unsigned. I mean, there's a lot of times when you've got things that really should never have a negative value input. Not only that, if you go and you make something unsigned and somebody tries to mistakenly put a value in there that's negative, it should fail. And that's actually what you'd want to have happen. All right. So here's some of the numerics. I'm not going to read one of them. All right. I will tell you that the only one that we will be using in earnest in here will be int. And we will be using int for our primary keys, which is going to be called _ID. By default, it automatically has this width of 11 digits. So imagine 99, 999, 999, 999. If I did my math right, that's 99,999,999,999, which should be plenty big. On the other hand, when we go in and we use numbers that can have a decimal point, I usually use decimal. All right. And with decimal, let's say that the biggest number I want something to have is up to 10,000. So $9,999, let's say, and 99 cents. Well, 9999.99 has 6 digits in it. And 2 of those digits come after the decimal point. So if I was going to create that as a decimal field, I would say decimal, then I would give it a size of 6, 2. 6 total digits, 2 after the decimal place. All right, here's the different string things. You find most people use varchar probably 90% of the time plus. Char is good because, for example, if I had a field called state, where you were mandated to put the state in there, and you were mandated to put it in as a 2-character thing, like MO for Missouri, of course, then you could set it to char 2, but it's fixed length. That's the key thing. Varchar is 1 to 255 characters, but it's variable length. All right. Now, a couple things about this. Notice we've got blob, tiny blob, medium blob, long blob. Blob is an acronym that stands for binary large object. And you can see when you look at these, they're all pretty much work the same. All right. But the sizes are different. Now, and if you look on here, what Traversy says is, I would not suggest storing images in a database. You don't. Typically, what you do is you store, like if you're grabbing it off the internet, all right, what you do is you copy the address and you store that in there as a varchar, because usually 255 characters are enough. If you knew it was going to be more, you could make it a blob, for example, which would store it as well. All right. Here's the date and time stuff. The one that actually gets used in there a lot is timestamp. All right. It says it looks like the previous date time format, but you don't have to worry about the hyphens. So many times when you come in and you create a variable, for example, maybe that I've got a list of users and I want a date that they joined. All right. So I create a field called date joined. I would probably make that a timestamp, and I would just use a default on it. And one of the defaults for timestamp is the current date. All right. But you can use regular dates. You can use date times. You can use times. You can use year. And you notice that with year, it's actually recommended that with year, you use the 4-digit format if you're going to use the year, because occasionally there's still something hanging around from 19 as opposed to 20. All right, for the first 2 digits. All right. The other thing is there's a minimal amount of math that you can do with dates, and it's pretty much what you think it would be. There is a date add function. So let's say that I wanted it set up so every time somebody ordered something, the ship date was 30 days from there, or the payment date was 30 days from there. I could set up a field and use some date math on there to do that. You can subtract one date from another. But other than that, there's not really very much you can do with dates. I mean, doing things like multiply and divide doesn't really make any sense with dates. All right. So this is, I showed you that before, but this is the thing for MySQL Workbench. And I will mention it a little later because it does have a couple things that are kind of cooler than what we get in PHP MyAdmin. All right. So when you come in and you start to create your own relational database schema, there are some rules that you should follow. All right, and hopefully most of these make sense. Each column value must be a single name or single value only. What does that mean? That means that if you are creating records, and let's say you're going to have an authors table, and each author will have an ID and maybe some kind of a book value of some book they're the author of. If a book has more than one author, you must make a separate record for each author's name because you cannot combine multiple authors into the same field. You can have an author name field or an author first name and an author last name field, something like that, but you cannot have multiple authors in the same field. All right. Much like what we have worked with in the past, this is very rigid. So in other words, if I say that a field can contain integers, that's all it can contain. It cannot contain non-numeric values. It cannot contain a decimal point. All right. Each column in a table must be unique. You could have 10 different tables, each that had a primary key of underscore ID, but since they're in 10 different tables, that's fine. Now, the next one and the last one kind of confuse people. The order of columns and the order of rows is insignificant. Now, most of the time, what most people do, let's pretend for a second that I was going to create an employee database. All right, I was going to have first name, last name, address, city, state, zip, and cell phone number. We'll just leave it at those 7 fields. I would probably have my order be an ID, followed by the first name, followed by the last name, followed by the address, followed by the city, followed by the state, followed by the zip, followed by the cell phone number. But I don't have to do that because when you write queries, you can order your fields in any order you want. So people typically do have a standard order, but it's not that you have to. All right. No 2 rows in a relation can be identical. The way that you make sure that that happens is you use primary keys. If you use a primary key, you've already got that one covered. And just like with columns, the order of your rows or records is insignificant. All right. All right. Now I'm going to hit you with a few things that you'll be like, okay, I sort of get this, but I don't get this. The first thing, because these are this is math terminology. The first one that's in there is functional dependency. And what it says is it describes the relationship between columns within a single relation. What that's saying is, in the example that I just gave you, so I've got an employee table. It has in there an ID, first name, last name, address, city, state, zip, and cell phone. So 8 fields. What I'm telling you is if somebody comes in and they can get my ID, my primary key, then they will be able to have access to the other 7 fields. So the other 7 fields, first name, last name, address, city, state, zip, and cell phone, they are all what's called functionally dependent upon the primary key or the ID field. All right, and that's kind of what he says here. Mine was longer, but I wanted to make sure you could understand it. All right. So common mistakes that people make when they're designing databases. And I probably did this in the example that I'm asking you to do. Tables with too many fields. All right. So you don't want a table that's got 25 fields in it typically. You want to break that up into 2 or more tables. All right. Tables that do not relate to each other. Now you may or you may not remember this, but when you were in the C# class, one of the things that we looked at in the Muroc C# book was there was a picture in there of the schema for what they called their MMA books database. The reason I'm telling you that is there were like 8 tables. One of those 8 tables was not related to any of the other tables. That's poor database design. We probably should have created another join table that had the primary key of that one table that wasn't connected to anything else and the primary key of another table. So indeed, we could bring that in. So you shouldn't have what are typically referred to as orphan tables. All right. Okay. Again, you shouldn't have things in a table that don't relate to one another. All right. Too many tables with similar data. Here's an idea. If I have an authors table, this is a hint for the homework that you're doing. But if I have an authors table and I've got, let's say, 30 authors, and several of those authors have created more than one book, all right, then in my authors table, I probably want to have a table that just has an author ID, an author first name, and an author last name. Then if I've got a book table, all right, hint, hint, if I have a book table, then I probably want to have one of the fields in the book table be that author ID. I only want to have to put the author's names in once. In other words, if I've got 3,000 books, I don't want to sit there. If I've got one guy who wrote 50 books, I don't want to put that in every time. First of all, it's time consuming. Second of all, I could make a spelling error. All right. And there are just things that can happen. You don't want repeated rows. All right. You want to use comma separated values in a single row. You'll see this a little later. You don't want poor naming conventions. All right. He's going to go through in just a few minutes a 6-step planning thing that he uses to make this better. Finally, you don't want typically non-normalized data. So what is that? Well, usually what database normalization does is it tries to minimize the amount of redundant data you have. The way that it does that is it typically takes large tables and breaks them up into smaller tables and has a foreign key in your child table, which is the primary key in the parent table. As it says on the bottom here, the objective of this is to isolate data so that actions in a field can be made in one table and then be propagated to any other tables, all right, as necessary. So when you do this, and I love this stuff, I'm not going to lie to you. When I did my doctoral thesis at the Illinois Institute of Technology, I was into databases, and my teacher knew it. Now, he actually met with me over a telephone or a TV rather. It was a lot like what you're doing. But I did drive down there a couple times and meet him. And we were talking once, and he said, you know, I've got probably 1,000 pages worth of notes on databases. He said, it'd be really nice if I would put those together and put them into a book. And I looked at him and I said, sounds like a master's thesis to me. And he said, for who? I said, you're looking at him. That's what we agreed to do for my master's thesis. I took all of his data and put it into a book. And I still have the book. He never published it, but I still have the book. All right. So when you're in first normal form, there'll be no repeating fields, no duplicate fields. All right. Each row, as it says, should contain only one value. Each row must be unique, and if you give each row a primary key, you're guaranteed that they're going to be unique. 1NF for first normal form is the easiest type of normal form to get. When you go, here is an example of 1NF. Now it says here this is wrong. Why? Because we're repeating the name twice. You say, well, that's not that bad. Well, what's going to be your primary key here? You can't have it be ID. You can't have it be ID and name. So your primary key must be a combination of ID, name, and membership. That stinks. So what you do is you take this one table and you break it up into two tables. So as you can see, now John Doe is ID 1 and Steve Smith is ID 2, but in the memberships, we've got the customer's ID, all right, and that's that 0 and 1 are over here. If you do that, you have put your table into 1NF or first normal form. Next is second normal form. If you want to get into second normal form, you must already be in first normal form. These are the requirements. Second, all non-key fields depend on all components of the primary key. All right. Here is one time where people sometimes break this rule. All right. I'm going to say something and you may disagree with what I'm saying. If you do, it's fine. But I was always told that if you give me a zip code, I can do a lookup on it and I can find out from a zip code the associated city and the associated state. Now, I've had people disagree with that. You can, I don't care. But the point is, if I make a table and that particular table, all right, has in it what I said before. So in other words, if it has first name, last name, address, city, state, and zip, all right, well, I've got the zip in there, and the zip, from the zip, I should be able to maintain the city and the state. So that's breaking it, because now I've got a non-key field, which is zip code, all right, and I've got other things that basically depend on that are not, and that zip code is not the primary key. All right, so some people would say that that zip code field should be in a table by itself. All right, problem is, how many zip codes are there? And as you'd guess, lots. All right, so here's an example of doing 2NF wrong, all right, and then doing 2NF right. You can see that in both cases, what we're doing here is we are breaking up typically one large table into two smaller tables. All right, and that's what we're doing here. Again, this membership, we've almost got two primary keys in here, an ID and a membership. So we break them up into two different tables. All right, but again, as I mentioned, this is an example. What some people do is they say it's not worth the trouble to put this thing into second or third normal form. There's actually, believe it or not, there are 7 normal forms, and you keep tweaking and tweaking and tweaking your database. And if you get into 7th normal form, almost always you've got a ton of tables that have an ID and just one value in them. So they have an ID field and just one other field. Most people don't go to and do that. It's just too much work. So for third normal form, you're in second normal form. And as it says, every non-prime attribute must depend on the primary key. And I already told you how you can break that. All right. So again, here's another example of it being wrong and then being right. This is kind of what I just showed you. So this is the zip thing that I just showed you. We're not going to worry. We're going to set our databases up. If this was a class in database design and we spent all semester doing this, we would have exercises on first normal form, second normal form, and third normal form. All right, I did when I took several of my database classes. All right. So here is going to be his 6-step design process of how he sets stuff up. Now, as he mentions here, every developer should have some kind of a process. And even a bad process is better than no process at all, because of having a process forces you into doing some things in a standard way. And that's usually what you're going to want. So as it says, he's going to describe a simple but effective process that he has used. All right. So first, define the purpose of the database and the applications that'll use it. Now, normally that sounds pretty simple, but as time has gone on, it is more and more important when you are doing this. It is more and more important to keep your end user in the loop. So you might go and do this on your own. Define the purpose of the database and the applications that'll use it. But it's important that after you do that, you either do that with the help of your end user, or at a minimum, when you get done with that, before going on, all right, you talk with the end user. In much the same way, if an architect had done something for a house plan for me and just assumed that, oh yeah, I want the door here when I don't, all right, I wouldn't want him to start creating the house and have that thing for the door when I wanted it someplace else. It's the same type of an idea. So he goes through an example in his. This is not the one we're doing, all right? But as it says, we want to create a database for an application website that will sell products, create customer accounts, allow customers to create reviews, and provide a basic CMS or content management system where you can do a lot of work in there. All right. We are going to hopefully have time to create something like this later, but it's not going to be what he does. So again, step one, define your purpose. Step two, determine your tables. All right. And you want the minimum tables that you will need. Again, you want to be able to explain this stuff in very general, generic terms to the people you're working for to find out if indeed what you're expecting and what they're expecting, excuse me, is the same thing. So these are the ones he came up with the example that he uses. Third, determine the fields that go in those tables. All right. When you're doing this, step 4 says determine your relationships. These two things bleed into one another, because once you've created your fields, then you're going to have to say, okay, this table will have to relate to this table will have to relate to this table, etc. So when you're doing that, at first blush, you're going to come through here and just say, what fields does this table need? When you come into step 4 and you determine the relationships, then you're going to have to determine foreign keys that you're going to have to put into child tables where you're putting in the primary key of the parent. Typically, that's the way you're going to do it. All right, step 5 then, you will create a diagram. I've already got one for you for what we're going to be working on a little bit later today. All right, and step 6, you go back through the entire process and you say, did I miss anything? Is there something here I do need that I don't have in here? Is there something in here that I have in here that I don't need? All right, says don't worry. Don't get worried if you forget some things or make errors, but the earlier in the life cycle process, you find something out, the cheaper it is to fix it. All right, what we're going to do after the break is, yesterday I tried to show you how to import that database. It didn't work. I have fixed it. It will import now. I will explain why it didn't work. But we are going to go in and through PHP-MyAdmin, all right, we're going to go to import. I am going to make sure you have the file that we need to import, and I'm going to make sure by putting it into a folder. So even if you can't get the GitHub repo to work, you'll have this in a zipped folder, and you'll just have to unzip it, and you'll be able to do that. But we're not going to export. We're going to click import, and then we're going to import when we go through that. All right, and we're going to go through all the steps. Basically, we're going to accept the defaults. When you export, that's what this one was. Typically, and it's kind of important, we're not going to worry about it now, but let's say that we've gone in and we've created our schema. So we've got a brand new database that we're creating, and we create the schema, and we're about to put our tables in there, our table data. What we might want to do first is export that schema, because what that'll do when we run through those steps like this is it'll put it into a file for us. Why would we want to do that? Just in case we end up screwing up the database when we put in our data, we could always go back. We've got a backup. So what a lot of people do is they export out their schema. Then once they put their data in, they go and they export the data. When you run through this, you've got your choice. And when you go through this, you can either, I'm trying to find it. You can basically, when you go through this, you can export, I think it's in here, but it's one of these. You can export just the data, just the schema, or both. All right. And it's going to create a file like this for you. And that file will have a lot of stuff in it, including something that looks like this create table thing. And this is the kind of thing you're going to do this yourselves when you create your own database. But for what we'll be working with, you'll have that stuff done for you. All right, this is so this will be the import that we will do. All right, and that's it. Like I said, I thought it would take until around 1 o'clock. It's pretty close. So when we come back from the break, all right, again, I'm going to zip the database for you, but we're not going to do that right away. Rather, what I'm going to do is I've got a couple more presentations that I've created on MySQL. Some of them will be at least somewhat repetitive of what we just looked at. So we'll go through these fairly quickly, but some of them will bring up Node and the like as well. So I want to go through those. When we get done with that, and I don't know how long it will take, then we will go up to that database, all right, and we will import it in, all right, and I'll be able to talk to you about what your assignment is going to be, okay? All right, so it is 12:57. Let's take 12 minutes and let's come back, please, at 1:10. I still have half of one. I should be fine. No, I don't. I'll take one. All right, sorry about that. I'm a minute late. I just sent you out an email before we went on break, and it's got the database we're going to be using. It's a MySQL database. It's called Classic Models 2. The original one was Classic Models. I'm going to explain to you a little later why it didn't work. All right, that is there, and there's a picture of the schema as well. We are going to look at that, just not right now, but we are going to look at that. All right. Now give me a second here. There we go. All right. Yep. Editing. Okay. Now, this presentation that I'm going to give you now, this is stuff that I've created and it's PowerPoint, but I want to do it quickly because I don't like doing PowerPoints. I don't like doing them probably any more than you like listening to them, but there should be some stuff in here that's worth looking at least that is my hope. So let me ask you if anybody can answer. Does this now say Unit 2, Node.js, and MySQL Part 1? Do you see that on your screen?
Yes.
Okay. All right. Like I said, I hope we can whip through these fairly quickly. But if you are having problems and you don't remember how something worked, etc., then hopefully this is going to help you. All right. Now, one thing that's in here, like I said, I'm just looking at this right now. It says node config organizes hierarchical configurations in an app. Yeah, that's true. We are going to be working with the config package amongst other things in here. All right. Now, are we going to work with Happy Joy? It's a way that it's something that you can use that will help you validate. So perhaps, but I'm not going to promise it one way or the other. Now, when you work with SQL, quite often you end up working with a package that's called KNX. As they say, it's an SQL query builder, and I'm not going to say any more about it. All right. Again, I am trying to set us up with a project that we can get up to a certain point. I can maybe get you 2/3, 3/4 of the way through it, and then say, now finish it and make it your own. All right. And I don't want to give you too much complexity. And the main reason for that is I'm supposed to be spending somewhere around a week on MySQL, and I'm supposed to jump into MongoDB. All right. So there is a MySQL package. Notice as it says there, it's the driver, the Node.js driver. It's written in JavaScript. That doesn't mean you still don't need something like a PHP MyAdmin or something that you can use to create MySQL. All right. Now, we're not going to probably use handlebars. We'll probably use EJS. If you remember, one of the things that I showed you yesterday was we made that public folder. Well, we actually didn't go far enough when we made that public folder. Typically, when you use one of these packages, and there's several of them, there's Jade, there's Handlebars, there's actually one called Mustache, but EJS is extended JavaScript. The reason I like to use EJS is EJS was actually created by the people who created Express. All right, so it really is made to work with Express. Okay, now, so you might say, then why do you have handlebars here? That's the one that Mr. Smith preferred. All right, and I've used them both. It's not that there's anything wrong with either of them. All right, Lodash is kind of a neat package. All right, and if you don't understand what that word is, an underscore is also known as a low dash. That's how this got its name. And what Lodash has in it, it's a utility library that has a bunch of different things that you can do to work on arrays and strings. And there's a bunch of other stuff that you can use with it. Morgan is a logger, so if you do need to log stuff out, there's different ways you can use that. Express router is something we will use not right away, but fairly quickly. I think I mentioned to you yesterday that what we don't want to have happen is we don't want to keep putting all of our routes into our app.js file. Rather, what we want to do is we want to put our routes into a routes folder, and each route will have a name probably with some kind of controller on it. Then we do what's called export that file, and then we import it into our app.js so we can use it. Sounds like a lot of work, but it's really a big separation of different things. All right, and it makes your project typically work a lot better. All right, so I'm not going to run through this demo. You can take a look at it if you're so inclined. Some of this is the kind of stuff we're going to be moving towards. All right. And there's some logging stuff in here. Like I said, I don't want to go through every single thing that's in here. All right, if you log, what you can do is you can log just about anything. Why would you log? Well, a lot of people do logging when they're testing to make sure everything is working the way it should work. A lot of people use logging when they have problems when they're writing code to see why things are not working the way that they should work. That might be it for this one. All right, so I'm not going to talk about that extra Express functionality. I am going to look at that particular example, not right now, but a little bit later, and see if it's worth us going through it, or whether I just decide it's not worth us going through it. So I'm going to close that. That's going to screw up my share, of course, but what I want to do is bring up the second one of these. So what you should be able to see on your screen now is Unit 2, Node.js, and MySQL Part 2. All right. And when I bring this up, a little longer presentation, but again, we're not going to go through every single thing that's in here. All right. Now this says review handlebars functionality. I'm just going to whiz through that. Most of the database terminology we've already gone through. So here's the different templating engines. This is what we're building towards, just so you know. We will be using EJS, embedded JavaScript.
There's nothing showing on your.
All righty. All right. Thank you. Can you see it now?
Yes, sir.
Okay, thank you. I appreciate it when you let me know. So we will look at this stuff as far as using templating engines, but we will have an app set view engine and we'll have EJS. That'll also necessitate us. We will have to install EJS with an npm I EJS when we get to that point as well. All right. Now this is some of the handlebar stuff. I'm not going to go through any of it. What you're going to find is when you use these things, you have to go and set things up in a certain way. So we'll do something similar to this, but we'll have a views folder. If you remember, we talked a little earlier about using MVC or model view controller. So the views are where we're going to end up putting our CSS, our HTML, etc., all that stuff. Again, I think what I'll do this weekend is I'm going to rewrite this, but I'm going to rewrite it using EJS. So you've got some examples using that. All right. Now, again, virtually everything that we're doing in this class that relates to database centers around CRUD. You know what CRUD is. We've talked about it already. All right. There's the definition that I found of a relational database management system and relational databases. Again, much of the material, I'll whiz through this pretty quickly because much of the material that you see here will be very similar to what I showed you before. All right. So you should now know what an RDBMS is. Edgar Codd is, as it says, the father of relational database design. He was a mathematician who brought this stuff into the computer age, for lack of better words. You should by now understand what a schema is. So really what a schema is it, and we'll look at one in just a couple minutes, but what a schema is, it gives you your table name, your table fields, your data types of those fields, and any constraints that you're putting in. What do I mean by constraints? Things like setting up auto increment, primary key, foreign key, and there's other things, indexes, and there are even some other things that you can put in there. I didn't want to get into too much detail with this, but there are things like that are called check constraints. So you can check, for example, to make sure that what the user puts in is greater than 0, just as an example. All right, so we've already talked about what a database is, what a table is, what a record is, what a column or field is. All right, you should understand all of that stuff by now. All right, and again, I know Mr. McLean told me before that when he went out to that URL that I sent you that it wasn't good, but sounded like from what you said, you can go through and kind of pick out the stuff that's in there. I think you should hopefully be able to click the code button in the upper right-hand corner and then go down and choose save as zip file, and then you should be able to get to all this stuff. Primary key, unique record identifier. Can't say that anymore. Primary keys, I think I've mentioned this in the past, but I'm saying it again for completeness. Primary keys should be unintelligible. That's why you do not use a social security number as a primary key. If somebody finds out whatever my Rankin ID is, the chances of them doing damage are a lot less than if they find out what my social security number is. But really, both of those fields, when you create a table, that's why you typically just create a primary key and call it ID or underscore ID, and you make it an auto increment field. Unique constraint. Let's suppose that we just, we weren't going to follow the right guidelines. And some people wanted us to use for a primary key in one table. Some people wanted us to use a social security number, and some people wanted us to use an employee number. And both of them were unique. All right. But you pick one and you don't pick the other. But the one that you don't choose, you want to make sure that it stays unique. So you can put the word unique in there, and you can put a unique constraint in there, which means there can only be one of that value in the entire table. Foreign keys we've talked about. Again, hopefully I'm preaching to the choir right here. As it says, you use a foreign key to link tables together. A foreign key can be more than one field. All right, but it's one or more fields in one table that relate to the primary key in another table. Again, the table with the foreign key is the child table. All right. The one with the regular, it's the child table, and the actual primary key in the other table, that's the parent table. All right. Quite often you create indexes. Again, we're not getting into it in that much detail, but if we were constantly doing, as an example here, if we were constantly running queries where we had millions of records and we were constantly doing things where we were searching for people by city or by state or by zip code, we'd probably put indexes on all those fields that we'd be using. All right. And an index, it's again, I've used this before. It's sort of similar to the index in a book. All right. If you had your C# book in front of you and I said, for example, int, what does int mean? You look it up in the index. All right. And it's kind of used the same type of way. Having too many indexes can slow a system down because every time you update a table, the indexes must be updated as well. You know what a query is. When you run a query, what comes back from the query is known as a result set. As it says here, the result set contains all the rows that satisfy whatever you put in for your query. If it comes back empty, that means your query was valid, but there was nothing that matched the criteria that you put in. A view, for lack of better words, a view is a saved query. So you grab this query that you're writing all the time and it's really long. Select this, do this, do this, do this, do this. So what you can do in front of it is you can say, create view X as, and then you put your whole query in there. Then when you want to run the query, you just say select X, and boom, it runs the query for you. A transaction, that is one or more things that you are trying to do. Now, the things about transactions, and it gets into talking about some principles that we may or may not get to in here, but when you've got a transaction, typically it's a bunch of operations that you want to perform, one after the other. But the idea is they comprise a unit. So if I try to do a transaction that's got 6 things in it, and the first 5 succeed, and the 6th one fails, the whole thing fails. And you do what's called roll it back to make it look the way it did when you started. So with a transaction, again, it's a bunch of different things that you want to do, but you will not commit that transaction unless everything that's in the transaction succeeds. Otherwise, as mentioned, you roll it back. All right, I already talked to you about normalization and the 3 forms. All right, as it says, there are higher forms. It goes from 4NF to 7NF, and then there's BCNF, voice cod normal form. All right. Sometimes you decide you've normalized too much, so you do what's called denormalization. And you take a database that maybe is in 3rd normal form and you break it down into 2nd normal. So the next one is part 3. Hopefully you can see that on your screen right now. unit node.js and MySQL part 3. All right, that's what we're looking at now.
It just went away.
All right, well, we'll get it back. Did it come back?
Yes, it did.
All right. All right, so again, this one will probably whip through real fast, some more terminology and some CRUD examples. So you know what MySQL is. For years, it was kind of the standard database that most everybody used. And not to lie to you, but the main reason was because it was free. Then it was bought out by Oracle, and that was actually several years ago. All right, so Oracle they're the ones who own it, but they still have kept the free version. Okay, but with the free version, you get basically no support. So if anything goes wrong, you're on your own, for lack of better words. All right. Yeah, we don't need that. So this is kind of what I showed you before. The data types, we talked about those. All right, here's an example. I'm not going to run through this. But if we were to go and actually create this and do it from a command line, this is what we type in. So we'd say create table employees, etc. You keep hitting enter and your prompt will change to an arrow. And when you get done and you hit enter, it'll come back. In this case, we're creating a table. There's nothing in the table yet, but if it comes back with 0 rows affected like that, it worked. All right, there's just another example. I'm not going to throw that in there. You know what selects are, or at least hopefully you know what selects are. All right. Now, when you start to do joins, there are several kinds of joins. There is an equijoin, which is shown here. There is a non-equijoin. There is a left join. There is a right join. There is a self join. One of the things that we're going to go over, in fact, I probably whizzed right by it, but I'll try to remember to bring that up during the break, is there's a pretty good article out there that explain joins and do it very much with pictures, so you can see what's what. And I'll try to grab that article during the break. There's different ways that you can write equijoins. We're going to look at both the older syntax and the newer syntax. All right. Okay. Let's see. A cross join is also known as a Cartesian product join. That's typically because you made a mistake. All right. And what that means is this says, show me every single record in the employees table, join it with every single record in the departments table. Give me every combination. So in other words, if there were 50 employees here and there were 10 departments here, that would return 500 records. Employee 1, department 1, employee 1, department 2, all the way through employee 1, department 10. Then it would have employee 2, department 1, etc. Most of the time, when you get a Cartesian product join, not always, but most of the time, it's because you made a mistake. You didn't mean to do it. All right. When you do a left join, the left table is the one that is the predominant table. So you're saying, show me every record there is on the first table. In this case, it would be departments, and only show me those employee records that match from the department table. All right. Otherwise, it's going to show null if there's no match. A right join is kind of the opposite. So we just flip that around. So instead of department and employees, it becomes departments becomes after the second. So if you list it first, the one you list first with a left join, that'll be the predominant table. And the one you list second with a right join will be a predominant table. Again, I think when I show you that article, it'll probably help your understanding this. Now, when you do your homeworks, and we're going to talk about that in a bit, but when you do, you have to understand group by. All right. So this says select department name and a count of department ID. This would show, since we're grouping it by ID, as it says, it would show the total number of employees in each department. And it would group it by department ID. So if we had 10 different departments, it would show department 1, then how many employees work in there, department 2, and how many employees work in there, etc. You will do a problem or problems similar to that on the worksheet I have for you. Sometimes when you do a group by, you have to put conditions on there. Having is to group by what a where clause is to a regular query. So having allows you to put criteria on a group by. Okay, so this one would say, this one says basically show me everybody, but this one says only show me everybody if they have at least one employee working for them. So that even if we had departments that were just created that had no employees, it would still show them. This would not. All right, the aggregate functions, the major ones that you're going to use for aggregate, there's 4 of them. There's count, there's max, there's min, and there's average. This thing right here says, give me a count of how many employees work in department 1. All right, with an ID of 1. The select star says, show me everything. All right, so that would give you a count of all employees that are in there. The sum, maybe I missed some, I don't know, but the sum that's in here, sum will only work on numeric fields. So that'll go through the salary of all employees in department 1, add them together. This will go through all the salaries of employee of department 1, find the smallest, find the largest, and find the average. So the average basically does a count. All right, and then it does a sum of all the salaries and divides it by a count of how many people were in there. Now, there are other ones that you can use in here, just so you know, there are other ones, but most of them typically aren't the kind you would use. And what I mean is there's variance, there's standard deviation, and there's things that you might use if you were writing a completely scientific realm program that we usually wouldn't do. So here's how we can add a new employee, and it's interesting because Mr. Knott no longer works for this institution. I don't think he'd mind me saying this. I considered him a good friend, but he's an anti-vaxxer and he refused to get vaccinated. All right, maybe he has since then, I don't know. But when you do an insert into table name, then you put in the fields, in parentheses, field names, values, then another set of parentheses, the values. So first name is a string, so it has to go in quotes. Same with last name. Department ID and salary are numeric fields, so they don't go into quotes. There's an update. So it's an update followed by the table name. Now it says here, set salary equal to 80,000. If we didn't put a where clause in here, I would have just updated everybody's salary to 80,000. So when you do an update, and as you'll see in a minute, when you do a delete, it's unbelievably important that you virtually always put a where clause in here. So again, this would update the employees table, and everybody who worked in department 5, their salary would now be 80,000. And there is the delete. Again, if we do the delete without a where clause, that'll delete all records from the table. You won't be asked, and there's no way to get them back again. All right, again, that's why it's important, as I mentioned earlier, to do backups on an as-needed basis. All right, you can also write nested queries. Okay, I didn't ask you to do one of these on the worksheet, but it's a query within a query. So what happens is you run this query right here. Select max salary from employees where department equal 1. Let's just say it was $100,000. All right. Then that output becomes the input here for select star from employees where salary equals $100,000. So you run the inner query first. You use the output of the inner query as the input to the outer query. And I can't believe I said that without screwing it up. All right, so that's the third one. So here comes the fourth one. If again, if you lose the picture on yours or it's not there, Michael, just yell something out to me, please. But if I don't hear anything,
It's
you see
empty
it
right now.
You can see it?
I cannot, no.
All right. Sometimes for whatever reason, this thing makes me go and do the share and then it makes me do the share again. I don't know why. Can you see it now?
Yes, sir.
Okay, thank you. All right. So I'm not even going to go through this one, but this is how you can use KNX along with this. I don't want to go through this because there's going to be some node stuff and some other stuff we haven't gone through before. So this one I can just totally skip. I'm going to find this first. All right, I'm going to try just doing it once more, so I'm sure you can hopefully at least so you can see it. Can you now see part 5?
Yes, it is there.
All right. Hopefully it'll stay there. All right. This, notice it says implementing CRUD interfaces with jQuery using Ajax. That's doing stuff on the client side. All right. But I do want to take a second to go through the get, post, put, and delete. I know we've talked about this a little bit already. All right. I'm not going to go through the Ajax stuff. All right. Get versus post. We have talked about this. I have mentioned some things about this. I'm going to continue to mention things about this. As it says, 2 common methods are get and post. Get, you've got to look at it as get does not change the data. Get is synonymous with a select statement that we have when we're working with a database. As it says, it's basically used for getting or retrieving data. Post is more like, basically what you'd use when you're doing a create or an update or a delete. All right. Post is typically post is used to send data to a server, but you can also use it to get data from a server. So a lot of times with a post, it's going to end up that you're going to have a form, and you can either fill out a form if it's blank and you can add a new record, or you can set it up so that it goes out to the database, queries it, grabs an existing record and puts it in there so you can either update it or delete it. Okay. All right. I'm not going to go through any jQuery stuff. So a couple things about the get statement. As it says, get requests can be cached. They remain in the browser history. They can be bookmarked. Okay, that's really actually a pretty big thing because with posts, you can't bookmark them. And the main reason that you can bookmark them is typically with a get request, all right, it's going to be about 4K or less as far as size. So they're not that big. Remember, with a get, you should never use them when you're dealing with sensitive data like passwords, credit card numbers, etc. And again, get requests are used only to request data and not to modify it. Some post specifics, as it says here, post requests cannot be cached. They do not remain in the browser history. They cannot be bookmarked, but they are much more secure. They have no restrictions on the data length. And what they do typically is in the headers, that's where they hide all the information. That does not mean that if you don't know what you're doing, you can't dig through a post request and possibly get some data you shouldn't be able to get. I may have told you guys this already, but I always found this interesting. When I was an instructor in Wisconsin, every year in March, we would have a conference up in northern Wisconsin, which never made sense to me because 2 or 3 times when we went up there, we had snowstorms. The point is this, though. A couple times they had a guy, his name was Joe. I can't remember his last name, but I know his first name was Joe. He knew more about security than anybody I'd ever met, probably. And what he showed was by going through some of these requests, if you knew what you were doing, that sometimes it would leave remnants of stuff that you wouldn't think was there. And he went through it and said, now, I'm going to show you guys this, but no one write this down and no one ever do this. But he went out there and he found credit card numbers, he found passwords, and a bunch of other stuff that should not have been able to be found. But people who wrote this and used post didn't really implement it in the right way. All right. Put, again, is when you're updating something. As it says, the difference between a post and a put, all right, is calling the same put request multiple times will always produce the same result. But calling a post repeatedly could have side effects. Don't have to really even worry about that. Delete is delete. All right, so that's this one. What you should see on your screen right now is Unit 2, Node.js, and MySQL Part 6. All right, hopefully that's what's up there right now. And we're going to go through that now. All right, in fact, this is jQuery, so this is client-side stuff. We don't even have to go through it. That's good. All right. And the next one, part 7, is more jQuery, so we don't have to go through that. And the last one, part 8, is even more jQuery and Bootstrap. So it's client-side stuff that I did. So we don't have to go through that. That's good. All right. Let me bring this up and I will change my share in just a second. I do want you to see this. This is one of the things that's out in that Git repo. All right. And just so you see it, there are working projects in here. I think they all work. I've got to look through them and update them, but I think they're all in there. I think they all work. Now, with some of these, you look at what is all this junk? All right. You'd have to know how to run it. All right. But and I don't even remember if I wrote these or I didn't. This looks like something I wrote. The other one didn't. And this looks like something I'd have written. All right. Now, what I'd like you to please do is what we did. Like I said, during the break, you should have been sent a zip file that's called classic models2.zip. All right. I'd like you to unzip that to where you unzip things. All right. I don't know if can I unzip mine here? I don't know. Let's see. Extract all. What should be in there? It's interesting. It looks like it's in there twice, but that's fine. All right. is you should have a file called MySQL sample database modified.sql and another one called schema classic models.ping. All right. If for some reason you didn't get it or it's not in there, you're going to have to let me know. All right. But what I would like you to do is this. I'd like you to unzip it if you have not already unzipped it. Okay. Then I would like you to start up XAMPP. So let me stop my share and restart my share here. So I'd like you to go into XAMPP and hopefully you can see that on your screen. If you don't have it up, bring it up. And when you bring it up, it'll look like this. You have to click the start for Apache and you have to click the start for MySQL. All right. If you've got those two done, you can click the admin that's right next to the button for MySQL. So on the second row, the second admin down, click that. And again, that will start up PHP MyAdmin, which you probably now cannot see on the screen. So I will again change my share so hopefully you can see that on the screen. Can you tell me, do you now see on your screen PHP MyAdmin?
Yes.
Okay. Now, I'm going to remove, I've already got this, the one we're about to put in, I've got it already, right there. So one thing it's going to allow me to do is I want to show you if you don't want a database anymore, what you do with it, okay? So you can't have the database open. You can't get rid of it when it's open. So you close it so it's not open. You go to new over here and then just click the SQL box and you type in drop database. So that's a DML or a data manipulation language command. And then the name of the database, Classic Models 2. And when you put that in and you click the go button down in the bottom right-hand corner, it's now gone from here. All right. So this is what I would like each of you to do right now, please. I'd like you to click the button or the link or whatever you call it up here that says import, right up there. Click import. All right. Can you still see on my screen, Michael, or does it say importing into the current server?
Yep.
Okay. And hopefully that's where all of you are. Then you want to click the choose file button that's right here. All right. And I've got mine set up to my desktop. Yours, you might have to iterate to wherever you save that. But I want to open my classic models and I want to find that file that's called MySQL sample database modified. Okay. Just click it and then click open. And that should change over here then and say that. All right. And once you've done that, we're going to accept all of the default options. So just click go and it should come back and look like this. If it doesn't come back red or pink, it worked. And now you have a new database over there that's called Classic Models. Did anyone try to do that and it didn't work? Because otherwise I'm going to assume you did it and it did work. All right. So just so you see this, this is a database with 1, 2, 3, 4, 5, 6, 7, 8 different tables in it. Now, let's see, where is that? If I click on the database to open it, so if I click right there, all right, and I go over to where it says designer, you can do this. You've already got a picture of it, but I just want you to see it. If you click on the database name itself and then click over here where it says designer, it shows you all the tables you've got and all the relationships between the tables. And this is a quirky tool. This is one place where it's better to actually use MySQL Workbench. It works a little bit better. But you can see you can drag them over and it shows you what is hooked up to what, etc. Now, what I did, just so you know, I'm going to change my share, but what I did, all right, no, not there, I'm not. see, let me open that up. What I did, I'm changing my share right now to it, is I made you a picture of it, and I saved it as a ping file. So these are all the tables and all of the relationships. Now, normally, I wouldn't have ordered these the way I've got them. In other words, normally I'd have employees up on the top or customers up on the top, not where it is. But this package was not working well today. I was dragging stuff back and forth. I drag it somewhere, I'd let it go, and it would just revert back to where it was. All right. So I'm just going to leave it right now the way that it is. All right. So you could make this yourselves. I'm not going to make you do that, but you could, if you wanted to, you could make this yourselves. All right. Now you'll notice when you look on here, this is kind of hard to see, but right on here, for example, I'm going between order and order details. When I go up to order details, it kind of looks like a little colored triangle in there. That's the many side. So one order has 0, 1, or many order details. One product line has 0, 1, or many products, etc. That's how you read this. This is not that different from an ERD or an entity relationship diagram. It is not the same, all right, but it's not that different either, all right? Now let's see, I want to make sure I didn't miss anything here. All right, I want to do one more thing and then we're going to take another break. But before we do, I want to change my share because I want to open this up. So where are we? Like I said, give me 5 minutes and we will take another break then. All right. Hopefully you can see on your screen right now, line 3, as I highlight it, whoops, and it turns gray. It says http://www.mysqltutorial.org. Can you see that?
Yes.
This is the file that you just imported. All right. When we tried to import it yesterday, it didn't work. And I want to show you why it didn't work. The stuff that you see in here in green is what you think. They're comments. Okay. So we created a database that was called Classic Models 2. And then we made it active by saying use. I mentioned this before, but I'm going to say it again. Where they come in here and they put these backticks, the only time you actually need backticks is if you've got a blank space in between words. So if instead of saying classic models, it looked like that. But technically, all of these backticks that are in here, they're not needed, just so you know. What happens is the software puts them in there. So I did not remove them. Okay, let me tell you real quick. There are 8 tables in here, all right? The first table is offices. There are 7 offices. You can read through there. I don't care what they are. This is the database schema right here. It says the table's name is offices. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 field or 9 fields in it. Office code, city, phone, address line 1, address line 2, state, country, postal code, and territory. All right. The primary key is office code. We could have put the primary key up here. And you'll notice since it's a varchar, we don't say auto increment because it's a varchar. All right. None of these can hold null values except address line 2 and state. All right. None of all the rest of them must have a value. All right. And those have a default value. If you leave it off, it goes to null anyway. But anything that says not null means you can't leave it blank. All right. So we create the schema. Then we've got the insert statements. Each one of these lines here, line 1, line 2, they each have a comma on the end, and they're in parentheses. So this is record 1, record 2, record 3, etc. Why they did this and made this a varchar instead of making an int 11 and doing it, setting it up with an auto increment, I don't know. I didn't write this database. So you can look at this. So the office code for the first one is 1. The city is San Francisco. The phone is that. Notice there's no dashes put in. For the address line 2, you would typically use that. So if my address was 123 Main Street, apartment 3, that's typically where you use that for, is for the second address line. Okay. So the reason this didn't work yesterday is I'm going down to employees here, and it says employees, in order to work, it's got 2 foreign keys. The first one is actually on itself, so you can do what's called a self join. Don't worry about that. But the second one references the offices table. Yesterday, when I tried to show you the example I gave you, this database yesterday, the employees table was listed before the offices table. So you were trying to set a foreign key up for a table you had not yet created. That's why it broke. So this morning I went through all these and changed the order of these around so that if we had any foreign keys, whatever table was being referenced was placed before that table. All right. Like I said, that's what I did. All right. So this is all that stuff in here. So again, we're going to take a break in about 30 seconds. But before we do, let me quickly change one more time. And I want to go back into the internet. All right, so we're back in here. So now we can come in, and for example, if I click on customers, you can see there's, I don't know, 20 some customers. All right. It says 122 total. There's 122 customers. It's showing me 24 on a page. These are all the fields, etc. This is the same thing that would happen if I came in with my SQL window and typed in select star from customers. If I put that in and I click go, I get the same results. All right, it is 2:03. I'm going to give you till 2:15. Then I'm going to come back and I'm going to run about 10 or 15 of these queries, fairly simplistic ones, to get everybody back in the groove, so to speak. I want you to remember how to do this stuff, and then I will look at your assignment with you. All right, and you'll have at least an hour to work on that today or to work on whatever it is you're working on for this class. All right, so it's 2:03. Come back, please, at 2:15. I'll see you then. All right, it is 2:15, so let's just take and run a few queries here just so you see them. All right, and again, most of the ones that I'm going to run right now are going to be simplistic. All right. So for instance, if I look at orders right here, I brought up orders, and these are all my orders, but I can also click on structure here, and it shows me how this is set up. So you'll notice I've got order number and I've got an order date in here. And then I can look down here and basically it shows me how everything was set up. So I can always go back and I can browse. I think it was browse. Yeah, and it'll show me the records. Now, you'll notice these are 2003, for example. All right. So, I mean, I could go back in there and run update queries and change the year, for example, where it was equal to 2003, we could change it to 2022 or something like that if we wanted to do that. But you should by now have at least a comfort level with something like this. Select star from orders. And again, you don't need those backticks. All right. How about if I wanted to know, select star from orders, I don't know, if I wanted to know how many orders there were. And that's actually one of the things you're asked. You could select count star, select count star from orders. And you'll notice, I can't make that bigger, good. So with select count star from orders, if I take that then and I run it, it comes back and it says I have 326 orders. All right, and you can do that on every table and find out exactly how many records are in there. And that's one of the things that you're asked to do. I can go over to employees. All right, and here are my employees. A couple of the questions that are in here, for lack of better words. All right, a couple of the employees that, or a couple of the queries rather than, they're kind of convoluted in that you might like, what the heck did you ask that for? Just because I wanted you to get practice doing some of these. So if I wanted to know how many employees worked at office number 1, all right, I could come in there and select star from employees where office code equal 1. All right, and then run that and it shows them to me. All right. Now I could have done a count right there, and then it would have shown me 1, 2, 3, 4, 5, 6. It looks like 6 employees. Now you'll notice that when you do this, it automatically puts them in order by the primary key, which is the employee number. But if I don't want that, all right, I can come back to here and I can select star from employees where office code equal 1. I usually go and take these and put each type of statement on its own line. You don't have to do that, but to me it reads better like that. And then I could say order by last name. I think that's what it was called, was just last name. And I can put it like that and put last name and then run the query by clicking the go button here. And now notice they are in order by last name, but they are no longer in the order based on the employee number. All right, and then just the same way, and it keeps all your last query in here, I could do it in descending order. And I think I mentioned this kind of thing to you before. You'll notice that select, from, where, order by, and DESC, I put them in capital letters. You do not have to do that. All right, I'm just used to taking keywords and putting those keywords in uppercase. So I can run that, and now it just reverses the order. So Thompson through Bow, for example. All right, so you should already have a comfort level with those. Notice that when I come over here, and once I've selected employees, that it shows me over here the fields that are in there. So if I change from employees to offices, and I go back to structure, all right, and then I go to SQL, now it's got everything in there for offices. All right. So many of the queries that are in here are fairly simplistic. All right. But what about the case where I want some information? I want some information, let's say, from the orders table. All right, so here's my orders, and there's my order number. All right, but let's say that, okay, let's assume I want the order for order 10,100. I want the order date, but I also want the details. So I go over to details here, and there's 10,100. So maybe I want to know the quantity ordered as an example. So that's when I'm going to have to go in here, and I'm going to have to select, not star, but I'm going to select, and there's different ways you can write this, but I'm going to write it like this. I'm going to select O dot order number. All right. And that's from the orders. And then from order details, I wish I would have kept that, but I didn't. So I'm going to just say, okay, I need the quantity ordered. All right. Now, I could get them both just from this table. So let's see, it's quantity ordered. Let's just say quantity ordered. We'll just keep it like that. And we'll make this orders. All right. So let's assume that from this particular one that's in here right now, where are we? There's our goal. Okay. That we want the order date from here, and we want the quantity ordered from the other table. All right. So we're going to assume we want what? Let's say we want the order number. So I'm going to say O dot order number. All right. And I'm going to say O dot order date. And then I'm going to say OD dot quantity ordered. Quantity ordered. All right. But then I'm using two tables. So I'm going to say from orders O, orders O, order details OD. All right. Where, and there's two ways you can do this. I'm going to show you the old fashioned way because that's the way I use. So I can say O dot order number equals OD dot order number. That's an equijoin right there. So I am grabbing information from two different tables right there. I'm grabbing information from the orders table, and I'm grabbing information from the order details table. Sometimes instead of seeing it written like this, you'll see it written like this. People will actually put orders there, and they will put orders there, and here they will put order details like that. And then you don't need this and you don't need that, but you would need to say where orders, and here you'd say order details. You'll see it both ways. But if I left it off, so I'm going to go change it back to the way it was. I'm going to come in here and I'm going to put an O here and an O here and an OD here. And I'm going to change that to O and that to O. And this I'm going to add, you can say as O, or you can just say O. Either one should work. All right. So as OD. The problem is if I were to remove this one right here, I'm going to get an error because there's an order number field in both the orders table and in the order details table. So if I try to run this right now, there's ambiguity. And it comes back when you get the pink screen, it usually means something bad. And it says column order number in field list is ambiguous. So it's letting me know what the error is. So if I just change that to O dot like that, and then run the query again, now it works. So I'm grabbing from the orders table, I'm grabbing the first field and the second field, and quantity ordered, I'm grabbing from the other table. All right. And again, I'm just trying to mention a few things to you. Now, when you look at these, those aren't terrible names, but we could make those names better if we wanted to. So I'm going to go back to the same query, and I'm going to say select O dot order number, and I'm just going to call this as and I'll put in here in double quotes, order with a number sign there. All right, and this, I'll put this over multiple lines so you can see it. And order date, and I'll say as order date. All right, and then finally the quantity ordered, and we'll say there as QTY. And I'll run it in just a second, but just so you know, if it's just one word like this, you don't need the quotes. So I don't need the quotes there. I don't need the quotes here, but I do need the quotes here. All right. So now that I did that, it looks like it doesn't like what I'm doing here. It says near O. So as order number. And alias was expected. Well, if I put it, maybe it does want it in double quotes, but I've never had to do that before. All right. I guess it did want it there. Maybe it was because of the pound sign. I don't know. But if I run this now, what you notice is my headings have changed. There's order number, there's order date, and there's QTY for quantity. The reason I'm telling you that, though, is because when you are working on the assignment, I want you to both alias the table names like I just showed you when you're joining tables, and I think it would look nicer if you aliased your field names too. So I'm going to bring that up, and I don't have it, of course, right there. Where is it? And it's not called that anymore. So let's see. I'm going to change my share in just a second here. In there. All right, so let me bring this up. Right here. All right, so this is the homework that I want you to do. Now you got enough stuff to do for Sunday. All right, so I am going to give you lab all period Friday as I've been doing, and I'm also going to give you a lab on Thursday. I want people to get done with this so you have an understanding of what's going on, and we can start working on a project where we're going to put this together with Node. All right, so I'm going to run through each one of these. Use aliases again. If you show me that you know how to use aliases, you get a point just for doing that. All right. You're going to use the database that we just brought over. The first 17 queries that are in here, I have written, and I've asked you to write them, and they're worth 2 points each. You get anything wrong on it, but you make an effort, you'll get one of the 2 points. If it's all correct, you'll get 2 points. All right, some of these I already showed you. Show the number of records in each table, now using that count star, so that shouldn't take you very long. So you'll put in there, for example, what I want the command listed. So you'll say, select count star from customers. And if there's 122 customers, then next to that, you can put 122. All right, write as 3 different queries. What is the biggest quantity ordered? That'll be using the aggregate function max. What is the smallest quantity ordered? That'll be the aggregate function min. What is the average quantity ordered? All right. Now, when you do that one, you're going to get a number like 35.12. That isn't right. So I'd like you to round that, but I'd like you to round it up. So if it comes back like 35.12, I want you to make it 36. I'm not going to tell you how to do that, but you can look it up. It's not hard. Number 2, or number 3, I should say. Show the number of employees at each office using one table. Order the results by the number in descending order than the number in office ascending. So in other words, if office ID 6 has the most employees with 8, and then office 3 has the next most with 7, that's the order in which they should appear. And if there's ties, so if you've got two office IDs that are the same, all right, then you should have them by office. So you'll do order bys on there. Okay. This one, I just thought it was fun. You might think it's a real pain in the behind, but you're going to basically go through there and figure out employees and last names. And there's different ways that you can write this. I'm going to show you on Monday. This is due Sunday. So I'm going to show you my key on Monday. I've only done the first 8, but I'm going to do all the rest by then. Number 5, show a count of the number of customers for each employee. So you're going to have to combine information from 2 different tables, possibly. Next, show a count of the numbers of orders for each customer. Next, show the total amount of payments for each customer. All right. Next, show the products in each product line. There are 7 different product lines and I think over 100 products. So if product line 1 had 50 products, etc. If you're not asked to do any kind of special sorting, then you can do it whatever way you want. Number 9, show the number of order details for each order. Then 10, notice what's the largest payment amount. So again, you'll use max on that. What's the smallest, you'll use min, and what's the average, you'll use AVG. All right. Then the hardest ones are 11 through 17, because you're going to have to join together 2 or 3 tables. All right. So you will grab the product name from probably the products table, the product line, probably from the product line table, and the text description is probably also from the product line table. So you will have to do a join on those. All right. All of these will be joins of either 2 or 3 tables. Then, like I said, I just ran out of time. So what I said was, I want you to make up 5 queries of your own, where you are going to be joining together a minimum of 3 of the tables. At a maximum, all 8. You probably don't want to do that because your query would be too long. I want you to explain to me what the query is or does and its significance. Now it says use the new join syntax. And I'm almost finished. Let me show you that, and then we will be done. All right. Here we go. All right. So what I just showed you was right here was this. Select this order date from these 2 where, okay. Now the other way that you can write this, and hopefully I'll write it without screwing it up, but we'll find out. You could say from orders as O, inner join order details as OD, where that's the case. The way I was taught to do it was the first way I showed you, where you don't need the inner join line. Rather, you list all the tables here, and then you just put your where clauses. But they came up with this inner join syntax. All right, they came up with that inner join syntax, and they did that thinking, at least, that it would run faster. So I should get the same results when I run this now. And it looks like I do. So again, I'm not going to run this because it would give me an error, but I can run it like this or write it like this. Or I can come in here and say, and not have the inner join in there. All right. So either one of those would work. And this says O, and that should say OD. So should that. Okay. All right. I'm not sure why it's giving me an error because I've got 2 selects on the same screen. I might even be able to put a semicolon there and have the error go away. There we go.
Mr. Scott?
Yes.
How do you want us to turn this in?
Okay, the question is, how do you want us to turn this in? What I would recommend you do is to create a file in Notepad++ or whatever, write your queries in there and then copy them in. And then once it works, just make sure you copy that thing out to Notepad++, something like that. Does that make sense?
Yeah.
Okay. I mean, if you want, you can put them in Word format because it's in a Word document. I don't care. All right. But I just want you to get some experience doing this. So when we do go in and start looking at this stuff in a little more depth and breadth of coverage, it makes sense to you. Now, there's one last thing I forgot because I said before I was going to show you this. Don't worry, you'll get your share back in just a second, I promise. But I wanted to show you one last thing. So where is that? It'll probably take me a minute to find it. So. Oh, it's not there. All right, I'm going to find it after we get done right now. I'm going to look for it. That was the article that I told you that was on different kinds of joins. And it did a really nice job of going through there and pictorially showing you what was in these different joins. All right. So I'm going to find that article right now, and I'm going to email the link to the article to each and every one of you. All right. Anybody have any other questions? All right, so we'll continue on with this tomorrow. You've now got about an hour and 15 or an hour and 20 minutes to be working on homework today. All right, since there are no questions, thanks for listening. I will see you at 12:05 tomorrow. Thanks.